On November 7, 2025, Russia confirmed fresh deliveries of Krasnopol M2 guided artillery shells to frontline units, as reported by TASS. The batches, shipped by High Precision Systems, Rostec, arrive amid sustained demand for point-strike munitions on the Ukrainian front. Moscow's stated objective is to accelerate precision effects while conserving stockpiles and compressing the sensor-to-shooter loop. The announcement matters because it indicates a deliberate push toward precision artillery as a counter to increasingly lethal counter-battery duels and electronic warfare. Rostec's Arms Cluster Director Bikan Ozdoyev underscored that such high-precision munitions are highly needed today. The Krasnopol family is Russia's long-serving precision artillery line, produced by KBP within Rostec's high-precision systems. The M2 variant is a laser-guided 152mm projectile designed for semi-active laser homing in the terminal phase. Operational employment in Ukraine with forward observers and UAVs providing real-time designation has enabled Russian batteries to pair precision effects with shoot-and-scoot survivability. The integration across a broad set of firing platforms, from Legacy 2S3 Akatsia and 2A65 MSTB to 2S19 MSTS and newer systems like the 2S43 Malva and 2A36 Giatsint B, reflects how Russia is normalizing guided fires across its gun park rather than confining them to a niche capability. On performance, Russian expert commentary claims a precision regime with CEP measured in low single digits and ranges that can extend to the mid-30s to 40 kilometers when fired from long-barrel guns such as Giatsint or Malva, while more common systems like MSTS/MSTB are associated with shorter envelopes in the 20 to 25 kilometers band. The latest 52 caliber guns like 2S35 Koalitsiya SV could, in ideal conditions, push the projectile to even greater distances. These figures reflect Russian claims and should be treated as dependent on gun system, propellant, atmospheric conditions, and designation quality. The core guidance method remains semi-active laser homing, not satellite navigation. Operationally, Krasnopol M2's utility in Ukraine hinges on the maturation of the fine fix-finish cycle at battalion and brigade level. Drones or forward observers laze from standoff ranges, while gun lines conduct short, timed missions, often targeting artillery positions, armor in defilade, command posts, and hardened strongpoints. The result is a lower rounds per effect ratio relative to unguided HE, a tighter counter-battery window for Ukrainian forces, and a better fit with Russia's emphasis on rapid displacement after firing. The synergy between laser-guided shells and UAV-enabled reconnaissance is often highlighted, with the system described as playing a key role in counter-battery engagements and in striking high-value targets with fewer shots. Against a peer adversary under heavy electronic warfare, the M2's main advantage is its independence from GNSS in the terminal phase. Reports throughout 2024 to 2025 described degraded performance for GPS/INS-guided rounds like M982 Excalibur under Russian jamming. By contrast, a laser homing round does not need satellite updates to finish the engagement, mitigating one major failure mode. The trade-offs remain clear. Line of sight is mandatory, atmospheric conditions and smoke can attenuate or break illumination, and the kill chain is vulnerable if the designator, often a small UAV, can be jammed, dazzled, or shot down. Ukrainian countermeasures are often described in terms of rapid mobility, decoying, and electronic warfare, all intended to complicate target acquisition and terminal designation. The industrial signal embedded in these deliveries is equally important. TASS's readout presents the Krasnopol M2 consignments alongside other guided weapons in ongoing batches, pointing to sustained output under the State Defense Order and an intent to routinize guided artillery use rather than treat it as episodic. In practical terms, more frequent precision salvos reduce the logistical burden per effect, shorten missions, and increase the penalty for signature exposure even several kilometers behind the line, particularly for guns, vehicles, small bridges, and makeshift command nodes that would otherwise require multiple unguided volleys. In comparative terms, Excalibur retains a standoff advantage when fired from 52 caliber 155mm guns at 40+ km, and it does not require a designator, which simplifies employment and reduces exposure of spotters. But where GNSS denial is acute and UAVs remain survivable in the near-front airspace, Krasnopol-type solutions can deliver repeatable point effects at typical gun howitzer ranges with less vulnerability to jamming. An overview of platform compatibility and observed use in Ukraine helps explain why Russia is leaning into this family. It offers a doctrinally comfortable way to raise baseline lethality across legacy formations without waiting for wholesale re-equipment. Strategically, these deliveries fit a broader Russian shift toward precision artillery inside a fires-dominant doctrine adapted to dense EW and pervasive ISR. By leaning on laser-guided shells that are less susceptible to GNSS interference, pairing them with ubiquitous small UAVs for designation, and feeding batteries from an expanded state defense order, Moscow aims to elevate the routine lethality of battalion and brigade-level fire missions while husbanding rocket artillery for deeper or time-sensitive targets. If production pace and forward survivability of spotters and drones hold, Ukrainian units should expect a denser pattern of point strikes against guns, vehicles, command posts, and bridges, forcing greater dispersion, deception, and rapid displacement to survive the first minutes after detection. The latest Krasnopol M2 shipments, as confirmed on November 7th, are therefore best read not as a one-off headline, but as evidence that precision artillery has become a daily instrument of attrition.